Welcome back to AERO 3170, Aviation Safety, presentation number 10 on textbook chapter 10 on airport traffic safety systems. In June of 1956, two transport aircraft collided over the Grand Canyon. What did this highlight? What changes were recommended as a result of this accident? Much of the airspace over the U.S. was uncontrolled over 20,000 feet before this time. And this led to the creation of the FAA and introduced modern radar systems and flight data recorders. Before 1956, there was no FAA, and there were no radar systems or flight data recorders in existence at the time. However, in December of 1960, when the FAA was just 2 years old, two transport aircraft collided again, this time over New York City, while they were in a holding pattern. Why did this happen, and what happened as a result? Well, one of the aircraft was a DC-8, and it had navigational problems and was flying at excessive speeds. The New York City towers lacked proper surveillance radar, so they couldn't really see the problem as it was occurring. As a result, equipment upgrades were made and new speed limit rules were mandated. This is when the 250 knot speed limit within 30 nautical miles of an airport below 10,000 feet came about. In January of 1982, the FAA released what was called the National Airspace System Plan. And it was a comprehensive plan over the next 20 years. It was a blueprint. It was meant to modernize air traffic control and air navigation systems in the United States. In April of 2000, the FAA Air Traffic Organization was created, or the ATO. The ATO is a performance-based department. It's focused on efficient operation of the U.S. air traffic control system. After the National Airspace System Plan expired in 2002, another plan was authorized in December of 2003, and that was the Next Generation Air Transportation System, or NextGen for short. NextGen is based on GPS, Global Positioning System, technology and computer technology. Rather than depending on the old radar-based technology, NextGen is moving toward more satellite-based navigation and digital communications. One of the most significant occurrences in the history of air traffic control happened in August 1981, after air traffic controllers in the United States went on strike. After the air traffic controllers went on strike over labor conditions, the FAA fired over 12,000 air traffic controllers. It took the FAA almost 10 years before staffing levels returned to normal. When discussing air traffic safety systems, it's important to understand the four categories of airspace designated by the FAA. The first one is called positive controlled airspace. Positive controlled airspace are areas that the FAA is responsible for separation of all traffic, whether it's under visual flight rules or instrument flight rules. Examples include Class Alpha airspace at 18,000 feet or above, or Class Bravo airspace at the busiest airports. The next category is controlled airspace. And controlled airspace is where the ATC separates IFR traffic, instrument traffic, but VFR pilots are responsible for providing their own separation from traffic, weather permitting. The next category is uncontrolled airspace. Pilots must provide their own traffic separation in uncontrolled airspace. And then the final category is special use airspace. This is where air traffic can be prohibited or restricted under special rules, such as temporary flight restrictions. There are three types of basic air traffic control facilities in the United States. The first one is air traffic control towers, or ATCTs. Air traffic control towers are the most visible facility. You can see air traffic control towers at Class Bravo airports, Class Charlie airports, and Class Delta airports. The next facility is called Terminal Radar Approach Control, or TRACON. These are approach controls usually at Class Charlie and Class Bravo airports. And the third is Air Route Traffic Control Centers. Air Route Traffic Control Centers, or ARTCCs, usually take over after an aircraft leaves a TRACON control area, usually at a certain altitude and above. There are three basic NAVAIDS, or navigation aids and radar surveillance equipment, that is used by the air traffic control system for navigation. The first one are known as VORs. A VOR is short for Very High Frequency Omnidirectional Range. A VOR is a radio station that broadcasts 360 degrees of radials from the station, and a properly equipped aircraft can use a VOR to aid in navigation. The second one is an ILS, or Instrument Landing System. The ILS can be used by an aircraft in limited visibility to guide it to a landing on a runway. And an ASR, or Airport Surveillance Radar, can be used by a controller to guide an aircraft to a landing on a runway, again in limited visibility. RNAV is short for Area Navigation, and RNAV is a performance-based navigation, or PBN, based on different technologies that will allow the aircraft to navigate on any desired course. It can consist of station-to-station navigation, for example from VOR to VOR, or it can use random waypoints offset from published routes. The Global Positioning System is the newest navigation system. It's based on satellites, so it's space-based, and it provides three different types of information. The first type of information is position. GPS can accurately determine where you're located on the globe. The next type of information is velocity, or speed. It can tell you how fast you're going. And also time. It can give you your estimated time of arrival or estimated time of en route. The GPS system consists of three different segments. The first segment is known as the space segment, and that consists of 21 satellites plus 3 operational spares. The next segment is the control segment, and that consists of 5 ground monitoring stations, 3 ground antennas, and a master control station. And finally, there is the user segment, which includes the antennas, the receiver processors that provide positioning, velocity, and precise timing to the user. Again, the space segment includes 21 satellites that orbit the Earth in 6 orbital spheres. And there are 3 operational spares, which can take over in case one of the 21 satellites malfunctions. The control segment consists of ground stations, 5 ground stations that monitor the health of the system, 3 antennas, and a master control station. The user segment consists of equipment in the aircraft. So it includes antennas and receiver processors. A vast improvement in the Global Positioning System is called WAAS. WAAS stands for Wide Area Augmentation System. Before WAAS, the Global Positioning System was not able to provide vertical navigation. In other words, it couldn't guide an aircraft down to a runway for landing. It could only provide horizontal navigation. With the advent of WAAS, aircraft can now be guided both horizontally and vertically. GPS provides several advantages over ground-based navigation systems like VORs and ILSs. Pilots will be able to navigate anywhere, including airports that lack ground-based systems. In addition, GPS will support performance-based navigation direct routes, and it will increase the number of published precision approaches, allowing pilots to land during inclement weather conditions. A recent change to the air traffic safety systems is the inclusion of unmanned aircraft systems, or UAS. Federal Aviation Regulations Part 107 applies to unmanned aircraft systems. UAS, or unmanned aircraft systems, are also known as drones, or unmanned aerial vehicles. Part 107 of the Federal Aviation Regulations is where you'll find all the rules and regulations as they apply to unmanned aerial systems, or unmanned aircraft systems. There are certain limitations on weight and also limitations on altitude that can be flown by UAS. Part 107 defines a small UAS as weighing less than 55 pounds. So anything less than 55 pounds is defined by Part 107 as a small UAS. Part 107 also limits small UASs to under 400 feet of altitude, 400 feet AGL, and only during daylight hours. Part 107 doesn't apply to model aircraft like non-commercial drones and radio-controlled aircraft. Also included in Part 107 are pilot requirements to qualify for a remote pilot certificate, and also operational rules. After August of 2016, drone operators who have successfully passed the written knowledge test and received a remote pilot certificate from the FAA can begin operations in Class Golf airspace at or below 400 feet AGL without contacting ATC. As the UAS industry continues to grow in the future, we should see changes to FAR Part 107. Well, that's the end of Presentation 10 on air traffic safety systems. The next presentation will be a review of safety data.